Okay, picking up where we left off on page 433, we're talking about the difference between symmetrical and asymmetrical digital subscriber line. Okay, let's look at the kind of speeds you can expect for these kind of technology. So cable TV is pretty doggone quick. I mean, you can get some good stuff. DSL, most DSL is kind of wimpy, and you can get some DSL packages that are pretty high, but the cost goes up rather rapidly. This is an older technology, ISDN. I used to have an ISDN modem at my house, but long before cable TV service was available. I could get ISDN, and it was interesting. This is the fiber to the house. You've probably heard of something called Google Fiber. So Google Fiber is a service that's only available in like a handful of towns. So if you happen to be in Kansas City or Austin or someplace like that, you get this really outrageous type of speeds. We're talking, typically we're talking a gigabit per second, which is just as fast as my internal LAN I have in my machine. So inside my house, I'm using what's called Gig-E, Gigabyte Ethernet. I'm using Gigabyte Ethernet between all my devices. And we're talking about a transmission and speed going out to the internet that's equal to the speed inside my home. Wow. Very cool. And ridiculously low price for what you're getting. But of course, if you're not living in Kansas City, it probably doesn't help much. Going back to this little diagram. By the way, I'm not gonna quiz you on the numbers. I'm not gonna say, what is this? That's not what this is about. A T1 line, you may have heard that term. This is what telephone companies do. If I'm going to set up a business, for example, and I've got a lot of phones, I can get what's called a T1 class of service that comes to my building, and I can split that any way I want. I can say I'd like 12 phone lines, and all the rest of this is going to be for data. Or I could say I want 2 phone lines, and all the rest is going to be for data. You can kind of split it and mold it any way you want, because it's basically just a bundle of channels, communication channels, and I can split them. A T3 is just more. Asynchronous transfer mode. This is not really a cabling kind of a technology, but it's a way to break things into incredibly small packets called cells, and allow them to transfer very long distances. There's a little note here that ATM can be used on top of existing technologies. For example, I take a TCP/IP packet and run it through this, and it'll just break it up, do its thing, and then reassemble it at the other end. So it actually is pretty doggone successful for these long-haul internet kind of services, between cities, things of that nature. So asynchronous transfer mode. Dun, dun, dun. Okay. On page 434, they talk about the communication devices. And so their definition is kind of wimpy. Any type of hardware capable of transmitting data, instructions, and information between a sending and receiving device. Okay, whatever. They give some examples. They talk about a broadband modem. Now, the term modem used to have an incredibly precise definition. It was shortening for modulator-demodulator, where you took an analog signal, converted it to digital, or reverse, digital to analog. So it was all about converting analog to digital. That's not at all what modem means now. Modem means it's a communication device. So they talk about a cable modem. That's what I have. I've got a cable modem for my cable TV provider. And so, yeah, I call it a cable modem. Yeah, like everyone else. But really, is there any real analog to digital going on in there? Not really. It's all kind of digital. The other one, the DSL modem. Yeah, again, hey, how much of that is analog? How much of that is, don't worry about it. It's just called a DSL modem. So these communication devices are practically just called modems. So, all right. Let's continue. Then we talk about wireless devices. On page 436, a wireless modem is, uses a mobile phone, So bottom line is, here's one of the rules of thumb. whenever you have a wireless communication, you're going to need somewhere in the system, it's going to be hardwired to the internet. Okay, it's just gonna. So for example, I have a wireless router in my home. All right, so I got my phone or my tablet, and I'm doing wireless to this box. But the box, the wireless access point, is hardwired into the internet. It's hardwired into my cable modem. Okay, so wireless doesn't mean completely without wires. It just means mostly without wires. You're gonna have to have it hardwired somewhere. And you always hear the story about, people in an apartment complex, and they'll call up and say, I can't get my internet anymore. And they go, oh, well, what happened? Well, my neighbor moved. Yeah, they didn't actually they were never contracted with the provider, AT&T or Sprint or whoever it was. They were just mooching off their neighbor through the wall. And when their neighbor moved, they complained that their internet was down. Well, they never had internet. At least they weren't ever paying for it. They were mooching. Okay. Wireless modem. Yeah, I think we know how that works. So towards the bottom of page 436, I show you what a wireless access point looks like. It looks just like a box. Typically, it's going to have, the old ones had like one antenna or two. Now they have like 3 or 4 antennas. Or I've got one that is so physically big. It's a big monster thing about this big. And so all the antennas are kind of built in. But you can get these little ones with these little antennas sticking out. I got a monster one. Anyway, and the idea is a wireless access point is all about hardwired to the internet at one end, and then allows for multiple wireless devices to connect. Cool. They talk about a router. On page 437, what a router is. A router is designed to connect disparate networks. So I have a network over here in building A, and I have a network over here in building B, and I want to connect the two of them together. I need a router that knows how to translate traffic from over here to sense that it needs to go over here and vice versa. So it's sort of like dialing the area code. If you're inside this building, I don't need to do the area code. If I'm inside this building over here, I don't need to do the area code. But when I want to send messages back and forth, got to use the area code, right? Same thing. So that's what the router does. The router says, wait a minute, this is long distance, quote unquote. And it says, let me do some fancy stuff here. So it figures out how to take that message, send it to a router, send it across the wire, and then have it come out at the other end. Okay, so connects multiple computers or other routers together, transmits data to connect. Bottom line, it's a device for connecting two networks together. That's the best definition. In most cases, we're going to be talking about home networking in just a few minutes. But my router, my home router, is a 5-port switch. Allows me to have 5 hardwired devices. It is a wireless access point. It is a firewall. It provides all that. So it's a router, and a firewall, and a switch, and a wireless access point, all in one box. Pretty doggone cool. Okay. On page 438, they talk about mobile hotspots. And, for example, my phone can be a mobile hotspot. I can use my 4G connection going to my phone, and then my phone uses Wi-Fi. It becomes a Wi-Fi access point. So let's say I'm at a conference, or I'm sitting in the lunchroom somewhere, and I fire up my machine, my phone, and I do a couple buttons. So I'm using the 4G signal coming to my phone, and then I'm broadcasting Wi-Fi. Then I fire up my laptop, and I can surf the net and do that through my phone. Okay, pretty cool. So I don't have to have, another subscription with the phone company for my tablet, because I got more than one tablet. This way I can have just one phone that can provide wireless activity for all my Wi-Fi devices. Now the only thing bad about that is I'm sitting at cafeteria. Other people can instantly see there's a Wi-Fi there, and they'll probably, hey, can I jump on your Wi-Fi? No, go away. Okay. There's a goofy little picture here of these network cards, and so that's a pretty legitimate looking network card, and one for laptops. But to tell you the truth, I don't see those anymore. Nowhere. I don't think anyone makes a computer, a desktop computer or a laptop that does not already have wireless capability. It's just not done. So, if I was in the business of selling these, I'd be looking for something else to do, because these guys are not being sold anymore. Not that they're not good. It's just that every machine I've ever seen in the last 5-10 years already has a network already built in. A laptop, can you imagine buying a laptop today that did not have wireless connectivity? That's insane. Okay, so this is kind of dumb, but it follows the chapter talking about communication devices. Okay. They talk about the difference between a hub and a switch. So I have a multiplexer kind of doodad. I have a device where I have one cable coming in and then it fans out to like 5 other devices. So if I only had one cable coming to a room in my office, but I had 3 or 4 network devices, I could put a hub in there. And so the one cable coming into the room, and then it would just splits out. And so I could hook up lots of different machines. That works fairly well. Now the hubs are kind of dumb. The hub doesn't even look to see what the traffic is. If it has a packet coming in, it just instantly rebroadcasts that packet on all 5 of the little ports. So if something comes in, it just says, I don't know who it belongs to. Let me just send it out to everybody. Well, you can imagine how that might be a little wasteful. Now a switch, on the other hand, looks just like a hub. Okay, physically they look the same, except there's a little bit of smarts in there. So when the switch receives a packet, it goes, hang on a second, who's this belong to? Oh, it belongs to port number 2. It only sends it to port number 2. It doesn't send it to everybody. It's not dumb. So the difference between a hub and a switch: hub is dumb. It just rebroadcasts everything. Doesn't even look to see what the heck it is. The switch says, hang on a second, let me find out who this belongs to. I'll send it to just that one device. Got it? Good. Let's continue. On page 440, they talk about the home network. And I've kind of already jumped the gun on that. I have a router, which is also a wireless access point, which is also a 5-port switch. It's also got a firewall capability. Most people, there's a little goofy diagram there. Most people don't run wires through their house anymore, or perhaps they never did. And so most people, if they have multiple devices, they get a router that has wireless capability, and they just go wireless. So rarely do you find people running Cat 5 cable or Cat 6 cable in their home. Okay. Let's continue. On page 442, they talk about transmission media. And there's some terms here. One is called broadband. Now, their definition is actually pretty doggone good. What it basically says is it's media transmits multiple signals simultaneously. What that means is I have a cable, and instead of sending having like one frequency that I send signals down the cable, I actually send multiple signals all at the same time. Now, to tell you the honest to God truth, almost all the technologies we talked about use this type of broadband technology, where they don't send just one signal. They send multiple signals over multiple ranges in order to be able to get more stuff down the pipe. So theirs is a classic definition and a very good one. But most people, when they say broadband, what they really mean is it's fast. Okay, that's all they mean. Do you have a broadband modem? And what they're really asking you is, are you on dial-up or not? So if you're not on dial-up, you've got cable modem or DSL, the answer would be yes, I have broadband connection. Although this is technically a better answer. The next one is bandwidth. And bandwidth, of course, is how many bits per second I can send through a communication media of some sort. And it's independent of the technology being used. So bandwidth really, really does mean speed. That's what they really ought to be asking you. Instead of do you have broadband, they should say, do you have high bandwidth? Kind of a strange, huh? Okay, this is probably a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.